Hi, my name is Ogheneovo Jatto, and I'm a student in Term 5 Electrical Engineering. I am currently taking a course called Electrical Design, and we're grouped into two. In my group, me and my partner were given a topic which was to design an Intel Galileo based data logger to get the temperature and current sensor of a small refrigerator consumption for a week. For that, but use an Intel Galileo with the shield on it for more accuracy. We also decided to use an LCD screen. It's not necessary, but just for us to get a clearer view of what is needed. These are our three sensors, which are connected to the shield of the Intel Galileo. This sensor is for the top part of the refrigerator. This one is for the bottom part, and this is for the room temperature. To get the current sensor from our fridge, we used a box, and in the box we soldered on our current sensor, so that all we need to do is plug this into the wall, then plug our refrigerator in here. For our projects, like I mentioned earlier, we need an SD card. This is 16 GB to store the temperature values and current values and get the average after a week. So, yeah, to power this on, we're meant to plug it in here to the wall first before connecting it to your laptop. Connecting to your laptop first before the wall can cause damage to this device. That's basically what the project is about. We're using 3 temperature sensors, 1 current sensor, an SD card, an LCD screen. Yes, that's it.
Now I'm going to take you through the program that we wrote for the Intel Galileo data logger. First, we had to go to Tools, then Board Manager to get the Intel Galileo board because it was not installed in the Arduino app. Then next, we also had to go to Sketch and get the correct libraries that we need for the code, which are the LCD, SPI, the SD card, and wire. Then we started by initializing the LCD and SD card. Then we named some variables that we're going to be using throughout the code, as shown here. Then we have 2 loops in every program for an Intel Galileo, which is the void setup and the void loop. In the void setup, that is where things that are only meant to run once are put in. Then in the void loop, that is where things that are meant to continuously run every time are written in. So we first of all did serial.begin for the SD card, then lcd.begin for the LCD. And then we initialized the SD card. Then we moved into the loop to get the time, because we need that for the energy consumption. Then we used A0, A1, A3 for the 3 sensors, and we read them out, then we do the conversion to get the temperature for each one of them, as shown temp 1, temp 2, temp 3. Then we serial print it to the serial monitor, which is located in Tools, then serial monitor. So then we had the voltage value 5, which is fixed because it's the same amount coming from the wall every time. So we assume the voltage is always 5. Then from the current sensor that was in the box shown earlier on, we read the value from there, then we do the conversion. So as known, power is equals to voltage times current, which we have the voltage and current value. Then the energy consumption is power times the time that we got above. Then this is to store, open the SD card, then store all the values that we get onto the SD card, which is shown here. Then that's how it ended. That's the whole code in a rush through, but to get more in depth, you could look up what each of those commands in the program means. Now, after all these connections, one current sensor is in the fridge, because the fridge doesn't have 2 compartments, but I'm going to test it out on a compartment with a fridge that has 2 compartments. If I open up this fridge, you can see it only has one whole section. So I just left the remaining 2 sensors outside. So that means I should get the same value for the 2 of them. So now I open up my serial monitor, and this is where it starts from. So this is the time, then these are the analog values for the temperature. Then this is the voltage, the current, then the power.
To those who may be listening, my name is Roland, and my partner and I have been working on a design to use an Intel Galileo to create a base data logger for a small refrigerator to determine its 3 temperatures, namely its room, fridge, and freezer temperature, and the refrigerator's energy consumption for a week. We used a 16 gigabyte secure digital card to log all this data into it. 2 main issues we came in contact with was a misconception of the use of the wall voltage as our base, but after discussion with an expert, a fixed constant voltage was the much better approach. As such, our group chose 5 volts. Another issue we came in contact with was our current sensor. Our analog read was taking any point on the sine wave, but the current value is decided by the peak value of the sine wave, as we all know. Thus, this was a big problem, and we solved this by building a low-pass filter with an op-amp. I enjoyed working on this project with my partner. The work was split equally, and it was plenty of fun. In this project, I worked on the SolidWorks design. I gathered all the components needed, researched the mechanical and electrical specs of the components, and ways it could be used efficiently to achieve safe and optimal results. Thank you for your time.
My main contribution to this project was the programming aspect, and I did a bit of research for what we need for the program, like the scale factor and the sensitivity for the current. Yeah, I also had to look up the values of the resistors that we need for the voltage divider circuit when the low pass filter and op-amp are also added. But my main work was the programming.
So that is the end of a brief overview of what our project is about, what we've done, what we need to improve on it. My name is Ogheneovo Jatto once again. Thank you.